Okay, so let's come to level 1A. So level 1A, first question. Diagram shows a uniform meter ruler of weight W being balanced by a 1.5 Newton force. Okay, so uniform, remember, means that the CG is at the center and therefore the weight acts from this center. Now balance means that we can apply principle of moments. Okay, so weight will act from the center, which is the 50 cm mark, since this is a 100 cm or 1 meter ruler. Now pivot is shown here. So this point itself, this is known as the pivot. Okay, the point itself. Now when we apply POM, we need to identify which force causes clockwise and which force causes anti-clockwise movements. So here we look at this force first. There's a 1.5 Newton force and it pulls the beam down this way. So this will cause a clockwise movement. Now the other force, because the pivot is here, so what happens is it will create an anti-clockwise movement because it itself causes the beam to rotate this way. Okay, so the labels are here, anti-clockwise and clockwise. Now under clockwise moments, we look at the force, so 1.5 multiplied by the distance from the pivot to get the moments. So that is 65 minus 70, we get 15. Take note that's in cm. We have not used the SI unit, and that is okay as long as you know what units you are using for distance. Okay, now next, your W is the force, because weight is the force. And what is the distance from the pivot? It is 20 cm. Now once you're able to write this, you can simplify the equation, right? So W will just be 1.125, you change to 3SF, you get 1.13. Now here's a proof. What if I want to use meters, which is the SI units, as the distance? So look here, force is the same, and for the distance 15 cm, I divide by 100 to change to meters. For 20 cm, I divide by 100 to change to meters. It doesn't matter, the final answer you get will still be 1.13 newtons. Alright, now question 2. Again, we are shown a uniform bar that's in equilibrium. So uniform means the weight acts from the center. So here I have my weight. Because how do I know this is the center? Because here to the left, it's 4 meters to the end. Here's also 4 meters to the right end. Now an equilibrium just means that I can apply principle of moments again. So I set up the statement. This statement is very important. Okay? And you decide again which forces are clockwise, causing clockwise movements, and which forces are causing anti-clockwise movements. So this F and this 12 Newton clockwise, this 20 Newton anti-clockwise because it causes the beam to turn this way. Okay? So clockwise moments, we have two forces causing it. The first force is F, so we ask ourselves, what is the distance of F from the pivot? It is 2 meters, so we write that down. What is 12? 12 Newton is 4 meters away from the pivot, so we write that down. Then for anti-clockwise movement, we have 20 newtons multiplied by 4. Alright, its distance from the pivot is 4. All these are in meters, so all the distances are in meters. Now hang on, we have a fourth force, right, which is the weight. Why is it not here? Okay, the reason is simple. This F is 2 meters away from the pivot. This 12 Newton is 4 meters. This 20 Newton is 4 meters. My question is this. What is the distance from the weight to the pivot? And the answer, if you're confused, it should be 0. Okay, so if the perpendicular distance from the weight to the pivot is 0 because it's directly here, then when you calculate moments due to this weight alone, it is also the same formula, force times perpendicular distance. Now this weight is the force, no matter what is it, doesn't matter because perpendicular distance is 0, it will not cause any moments. So because of that, we can ignore it. So the general rule is this, any force that acts from a pivot will cause 0 moments, or in other words, no moments, because the perpendicular distance is 0. So we can ignore the moments due to this force. Not ignore this force, we just ignore the moments due to this force. Now you find that when you simplify, your F is 16.0 newtons. Now a common error is to to do this, can we simplify this part? Some of us will do this. We will take the clockwise moments to be the total force, which is F plus 12, since I have these two forces, multiply by the distance, which is 4 meters. Now, can we do that? The answer is no. Because when we do that, what we are saying is that both the F is multiplied by 4, the 12 is also multiplied by 4. Meaning that we are saying the force F is 4 meters away from the pivot. But in reality, it's just 2 meters. But the F is not, so we cannot use this. Okay, so you have to partner each force to its distance from the pivot and then add them together. Okay, question 3, same thing. Uniform means weight is at the center, so we draw it in, and because it's acting at a pivot, we can ignore the moments due to this weight. It will cause 0 moments. So we are left with 2 forces. Alright, one is by an object, and one is a 5 Newton downward force that we don't know where to put, but it must achieve equilibrium. So this object has a 20 Newton force. It causes an anti-clockwise moments. So where can I put my 5 Newton force to balance this anti-clockwise moments by causing a clockwise moment? So I know that I have to put my 5 Newton force on the other side of the pivot. Okay, this is like a seesaw after all. So when I put it here, I can balance this object. Now, do I know the distance from the pivot? I don't know. That's why I name it D. Okay, now at equilibrium, we can achieve POM again. So we apply it. So sum of clockwise moments equals to sum of anti-clockwise moments. The clockwise moments will just be the force multiplied by distance from the pivot. Anti-clockwise is 20 Newton multiplied by the distance from pivot. Here you solve, you get D equals to 40 cm. Alright. Now, this is not the complete answer because we need to determine the position. So when you're writing your position, you need to be clear where you're talking about. So the position can be 40 cm to the right of the pivot. And that's what you should write. Now be very specific. Do not just say 40 cm away from the pivot, because away from the pivot can mean two things. It can mean the left side or the right side. So be specific, 40 cm to the right, and state your reference point, which is the pivot. Now question 4, we have a diagram that shows a balance in use. Now the object is balanced, so again we can apply POM. And this time we are given the mass, not the weight. Oh no. So how do we calculate the weight of this object? So never mind, we write out our first key point first, which is the sum of clockwise moments equals the sum of anti-clockwise moments. Again, identify the forces that cause clockwise moments and anti-clockwise moments. Under clockwise moments, we know that it's due to the object W, its weight, multiplied by its perpendicular distance from the pivot. So that's 12 cm. Then again, we have anti-clockwise moments, but this time we are given the mass, so we convert it to kg, which is to divide by 1000. So you change it from grams to kg. And then we multiply by 10, because the weight is your mass in kg multiplied by 10 Newton for every kg. Multiply by perpendicular distance. Write out everything nicely like this first, then you simplify the left hand side to be 12W. You use your calculator to simplify this. You will get 2 times 15. Okay, then simplify again further, you get W equals to 2.50 newtons.